Assalamualaikum and hello everyone. My name is Hazirah. Together with my group members from class FRIS 1204_7, would like to present a subtopic from basic chromatography, which is paper chromatography under planar chromatography. This video is about the analysis on the components of dyes in candy using paper chromatography. These are my group members. We have ZAHIDAH, ADIBAH, me, Hazirah, and IMAN. Do you have a favorite M&M's candy color? Have you ever wondered what dyes are used to make that particular color? If you do, watch this video to the end to find out what dyes are used. Let's go!
Hi, my name is NOOR binti AZIZ. Before we headed into our main point, let's take a look at the background of paper chromatography. Let me give you an example. If you ever seen a drop of water hit a printout from an inkjet printer, you know that when this happens, the ink starts to run. The water is absorbed into the fiber of the paper by capillary action. As the water travels to the paper, it picks up ink particle and carries with them. This same process can be put into a good use as a technique called paper chromatography. You know that actually chromatography includes a group of techniques that are used to separate various components in a complex solution. In each chromatography apparatus, there is generally a mobile phase, which is a fluid that the components are dissolved in, and a stationary phase, which is the material the fluid moves through. For example, in paper chromatography, water is the mobile phase and the paper is the stationary phase. The solution component ideally move at different speed as they travel through the stationary phase so that they can be separated. In paper chromatography, different pigments can be separated based on their solubility. A pigment that is more soluble than another will generally travel farther because it will be easier for it to dissolve in the mobile phase and be easier to carry with it along the paper. Meanwhile, a pigment that is less soluble than another will generally travel shorter because it will be harder for it to dissolve in the mobile phase and be harder to carry it with it along the paper.
My name is ADIBAH ZAWANA binti IQBAL, and I will be explaining about the theory of the experiment. In this experiment, the dye content of the shell coating of M&M candies will be analyzed using paper chromatography. The original candy featured a semi-sweet chocolate filling, which was referred to as the plain normal type after additional variations were introduced. The colors of M&M candy shells are created using food coloring pigment that is FDA approved and has various RF values. Some dyes cause allergic reaction in some people, thus they must be disclosed as an ingredient in items that include them. Paper chromatography is a variation of partition chromatography in which the cellulose support is in the form of a sheet of paper. Even after being truly dried, cellulose still has a significant amount of water in them. Partitioning takes place between the developing solvent and the warm water.
Right, next we move on to the methodology. Firstly, the preparation. Make 1-inch broad strips out of paper towels. Make sure that each strip is at least an inch longer than the large jar's height. For the food coloring samples, cut 3 strips, and for the M&M colors that want to test, cut an additional strip. Mark each paper strip with a pencil to indicate which candy or food coloring will be noticed on it. 1 inch or so from the bottom end of each paper strip, draw a pencil line. Next, mix 4 cups of water and 1/8 teaspoon salt in a large dish or pot. Do half fill a 14 teaspoon measuring spoon to achieve roughly 1/8 teaspoon. A huge jar with a small entrance should only receive a modest amount of the salt solution, around 1 inch worth. So the procedure: place 1 water drop on the empty plate. A red colored M&M candy should be placed in the water drop and left for 3 minutes. Turn the candy over so the other side is in the water droplet after 3 minutes. Continue to leave it there for 3 more minutes. Next, take the candy out. Place the pencil line made over and drop the colored water on one of the paper towel strips that have been created. There will be notice how the dye has colored the areas surrounding the line and soaked into the strip. By dabbing the sides of the wet candy with it, more dyes can be added to the line. The next step is use a different strip for each M&M candy, as when repeat these steps with the additional M&M colors that want to test. Create a strip for every food coloring. The line on a fresh strip should be softly tapped against the plate with a little drop of food coloring. Repeat until there are presence of 3 food coloring strips. Gently insert the pigmented end of a strip into the saltwater filled container. The strip should only touch the salt water when it is fully submerged in the jar. Use a clothespin to fasten the strip stop over the jar's opening. Make sure that each strip only contacts with the jar when it is attached and not the sides of the jar. Make sure they don't touch the jar side or one another when you insert, and secure as many of the additional strips as will fit. Allow the water to gradually ascend the strips until it is only an inch or two below the top. At this time, take the strips off. Keep a tight check on the water, because if the strips was left run for an excessively long time, the water may reach the top of the strip and affect the result. If the other strips did not fit in the large jar, place them in another jar and run them until they are finished similarly, just as that has been done with the other strip. Allow the strips to dry completely. To do this, place them on a drying rack or on a flattened clothespin. Lastly, observe the strips. How many distinct dye components are there in each M&M color, and name the colors that are likely included in M&M's candy as well as those in food coloring.
Now that you know the procedure of the experiment, let me show you the example of the result. By the end of this experiment, you will get something like in the picture on the left. All the color in the candy dye can be seen on the paper chromatography. Looking at the ingredient list on the packaging can help you determine which FD&C dyes these are. Blue M&M use one of the same blue dyes, and red M&M share one of these red dyes. You can figure it out which by looking at their packaging. If you try brown M&Ms, you probably saw that they contain a red dye, the same one as red M&M, and a blue dye. Green M&M also use two dyes, a yellow dye and a blue dye, although the latter may be too faint to easily see. Yellow M&M use the yellow dye. Now you know all the composition of food dye in the candy M&M.
In conclusion, paper chromatography is the separation of a sample combination into its constituent parts. In this analysis, 5 M&M's candy colors have been used, that are red, green, yellow, blue, and brown. Firstly, red uses red dye, green uses yellow dye and blue dye, yellow contains yellow dye, blue has blue dye, and lastly, brown uses red dye and blue dye.
For the references, this is the list of references that we use to complete this task.
And with that, we end our presentation. Thank you for watching.
Don't forget to like
and leave a comment.
Bye!